Hello students, welcome back to the another session of our artificial intelligence. In this video, we are going to cover that is breadth-first search in artificial intelligence. Last video, we are already cover what is the need of search strategy, because in case of artificial intelligence, the intelligence system consists of two things, that the agent as well as the environment. For agent, like the goal based agent, or we can say the problem specific or problem solving agents or rational agents, require some searching path if there are more than one solution present for a goal, for if the goal is given. But to achieve the goal, if there are multiple ways present or multiple possibilities is there, then which one agent has to choose? So for that, it go for the some searching strategy. So in between that, what are the different category, what are the different types, we are cover in the last video. In description section also I put the link so that you can refer it. In this video, we are going to cover the breadth-first search strategy in the artificial intelligence. So it can be called as the brute force algorithm, or it can be called as the blind search algorithm, or it can be called as the uninformed search algorithm, because it starts searching without any prior information. No information is given except that how to traverse. Means only information is provided, that is the how to traverse. More than that, no information is given. It is generally common strategy for the graph or a tree. So this is a very common approach we generally use for the searching a graph or searching a or traversing a tree. This algorithm starts searching from the root node of a tree or start node of a graph. Then it expand all the successor node at the current level before moving to the node of next level. So this algorithm implements using the fast in, fast out queue data structure. Queue is a data structure where insertion is done from one end and deletion is done from another end. And the principle it is in use, that is the fast in, fast out. Means the element inserted into the queue is going to be delete the fast. So this is the principle it follow. And here for the BFS search algorithm, it use this algorithm. What is a queue data structure? How the operation is going proper? I have already completed one video in the data structure. So I will in description section also I put the link. You can refer it. So here we have to analyze how the breadth-first search algorithm traverse, because it can be traverse. This searching we can able to use in a tree or graph. Let's start for the first one, that is the traverse of a tree. Now next question, where we have to start? As it is a tree, so we have to start from which node? From the root node. So this is our root in this diagram. So from this node we have to traverse. In case of queue data structure, what happened? Insertion and deletion is done from the separated. So insertion is done from the front end, sorry, the rear end or tail, and in deletion is done from the front end or head of the queue. So fast in, fast out. So this is the position, or this is the area where the insertion is going to be done. So it is called as the rear or tail. So this is the location where the element is going to be delete. It is called as the front of the queue, or we can say this is the head of the queue. So now we have to traverse through the breadth-first search. So breadth-first search, here what happened? We are already know what is the principle it follow. The principle it follow that BFA algorithm starts searching from the root node of a tree, then it expand all the successor node at current level before moving to the next level. So first is expand all the successor before going to the next level. So here we can say this is the level 0, this is level 1, this is level 2, This is level 3, this is level 4. So there are 5 level is present. So now first level, that is the root A, that is the label also 0. So first we have to insert the A into the Q. So this is the Q is present. So Q of how many elements? 1, 2, 3, 4, 5, 6, 7. So there are 7 elements can be stored at the Q right now. So we insert the value of A. So now what happened? So we have, once this age means after next iteration. This is the first iteration. First iteration, we have to store the root data into the queue. Then what happened? Whenever we go to the next iteration, so first element we have to remove from the queue and make as a visited. So right now we have to remove this one. So we make the A as a visited node, and all the successor of this root we have to put into the queue. Now, what are the successor? B and C. So, B and C we have to insert into the queue. Now, next question, which sequence we have to insert? Here, first I insert the B, then C. It can be possible C and B. It is not mandatory that we have to insert or we have to follow the sequence left to right. Any sequence we can able to do. We can perform B to C or C to B. Any sequence we can able to do. But only thing is that insertion should be done, this deletion should be done from this side. Now, next iteration, what happened? The element present inside the front position of the queue is going to be deleted and make as a visited. Now we have to delete this one and we have to make the visited. Then what happened? All the successor of this node we have to put into the queue. Now B successor is D, then E, then F. So three successor we have to put into the queue. Next iteration, front element we have to remove and make as a visited, and all the successor of this node we have to put into the, so C successor are G and H. So we have to insert into the Q is as a, so because this end we can insert the element. Next iteration we have to remove and make as a visited node, and we have to insert into the visited node. So you can make this is a one queue where the visited node is present. Now whatever successor of D we have to put it, but there is no successor, no nothing we have to insert. Now next iteration, this element we have to remove and we have to make as a visited one. Then F, G, H, and all the successor of E. Successor of E is present. Yes, it is present, I and J. So what we have to make? We have to make I. Then we have to make this is J. Next iteration, front element we have to remove and we have to make as a F. So this is G, H, I, J. And all the successor node of the visited node. So if there is no successor is present, so what happened? Nothing to be insert. Next iteration, front element we have to remove and we have to make as a visited one. Then as it is removed, so this element is shifted like this. So this is the shifting is going to be done. So all the details I have already make the separate video of that is the queue operation. If you want to go details of this, you can refer this one. I will definitely put in the description section. Now all the successor of G. Is there any successor? No, there is no successor. Then what happened? Next iteration we have to make this one as a visited node. So this is visited. Then what happened? I, J should be present. Now, whenever we remove H, what happens? Successor is K and L. So K and L store inside this one. Then we are remove the I next iteration. I means there is no successor. So simple J, K, L. Next iteration. So here what happened? I, J. Here only K, L. For J, NP is present. Successor. Then we have to remove the K and make as a visited. Then N. Then we have to remove the L. Then what happened? NP, then successor S is QR. So now we are visited all the nodes. So this is the way BFS traversing is going on. Now you just see A, B, C. So what happened? First A, then B, then C, then D, D, then E, then F, then G. So this is the sequence it's follow. So what happened? All the traversing is done sequentially. So each and each every layer is going to be traversed. That's why it is called as the level wise traversing. Means first we traverse this level, then we traverse second level, then third level, then fourth level, so on. So how the elements are traversing? It traverses on a level wise. That's why BFS also is called as the level wise traversing. So next we let us understand how to perform BSA traverse in a graph. So this is a graph is given. So in case of graph, we can start the traversing from any node. Here what happened? How many number of nodes? 1, 2, 3, 4, 5, 6, 7. There are 7 nodes. We can start from 4, 3, 2, 5. Any node we can able to traverse. So for example, we have to traverse from the 1. So we make this node as a start. So now what happened? First start node we have to insert into the queue for fast iteration. So second iteration we have to remove this one and we have to make this one as a visited. Then all the successor, all the successor means from this node how many number of node or path is available. So now from 1 2 is present. This is the arrow symbol means from 1 we can move to the 2 as well as 5. So what we have to, here also same thing, I can put the sequence 2, 5 or 5, 2. Any sequence we can able to do. So for example, I write down 2, 5. Then this element, next iteration we have to remove and we have to make as a visited. So what happened? 5 comes to the first position. Then all the possible or all the successor, all the possible path from 2 to any node we have to put into the queue. So from 2, 3 is possible. So we put 3. 2 to 6 can be possible. So we store C also. 2 to only this 2 is possible. That is 3 and 6. Then next iteration we have to remove this first element, that the 5, and we have to make as a visited here. This is 5 visited here. Then 3, 6. Whenever we remove 5, all the successor of possible path, that is 3 and 6, which is already present. So no need to do anything. So next one is 3 is going to be removed and make as a visited. 6. Now from 6, 4 and 7 is possible. So what we have to write down here? 6, 4, 7. So now all the route is visited. So this is the way the breadth first search algorithm traverse in case of a graph or in case of a tree. Next, we have to find out whether the BFS is complete or not, whether it is given optimal solution or not, what is the time complexity, and what is the base complexity. Let's start first one, then the completeness. So, in case of BFS, what happened? If it traverses each and every node level wise, so definitely it will give, it is a complete, because if any solution, if the goal node is present, then definitely it will find out, so it is complete. So here it is, yes, it is complete. Next one is the optimal, means the solution given in the optimal solution. Yes, yes, because if this is the goal node, then if we are define each and every node has a path cost is one. So what happened? If it traverse, definitely the path cost is cheapest path cost. So we can say that algorithm is optimal if the path cost is non-decreasing function of depth of a node. Then time complexity. Time complexity is generally the measure of time for an algorithm to complete this operation. Now, here what happened? In case of BFS, we are represent B with the either the order of people. The reason is that B is the number of total number of vertices, E is the total number of edges. But in case of artificial intelligence, we are represented by the branching factor. So here B is the branching factor, or we can say set no number of nodes at a salvaged solution, or any level what is the number of possible children, means here this is the branch factor, so this is, so what happened, according to that we have to find out. D is the depth of salvaged solution, so depth of salvaged solution. So this is the time complexity of the BFS. Similarly, space complexity, which can say space is complexity is the maximum storage space required for any movement during the searching process. So here also order of B to the power D. B is the branching factor. D is the depth of the salvaged function. The next one, how the agent extracts the path for an goal. So this is the big question, because we are already know what is the PFS. But our main objective, how the problem solving agent or rational agent find out its path for a goal. For example, this is the goal node. Then what happened? It left this one. Then it go to the parents. See, then its previous parent A. So it will traverse the parents up to root node. For example, R. So then what happened? It will traverse all the route to God. So if we go for the BFS, then what happened? A, B, C. So it will traverse all the path to reach the R. But once they reach the path, it will be try to find out which one is the parent L to it. Once the goal is node is find out, then path for goal is A, C, H, L, R. So this is the way the agent decided the path for the goal node R. So next we have to know what are the advantage of the BSF algorithm in artificial intelligence. First one is that it provides the solution if any solution. Definitely, that's why it is called as the complete. If it is present, definitely. Then there is no more than, if there are more than one solution, means for a goal, there are more than one solution is present, then what happened? Or for a problem, then This algorithm provides a minimum solution with less requirements of number of steps. Then what are the disadvantages? It requires lots of memory since each level 3 tree must have saved the memory to expand the next one. So this is the main drawback because each and every level the tree requires the more data to store. Second one, lot of time also is required because the if the goal node is far away from the node because it has to traverse each and every level. That's why it requires lot of time or time consumption is more. This is all about the breadth-first search algorithm in a artificial intelligence. So you are able to understand the concept. If you have any doubts, you can write in the description section. I will definitely try to solve it. Thanks for watching the video. Please subscribe the channel, like the channel, and share the channel.